Okay, so we left off last week. We were talking about hip roofs and hip truss or hip rafters. And remember, we were looking at a picture similar to this. And we were talking about conventional roofs where the slope on the hip and the slope on the main roof were the same. So let's say we have an 8-12 slope here. And we'll give this a 40-foot span. Anybody remember what step 1 is? Step 1 is the common rafter. The common rafter is found by taking a slice in the main roof here. And if we take that slice, remember what it actually is it's a truss. It looks like this. The width of this, the span down here, is going to be how much? 40 feet. And it is an 8-12 slope. So yeah, what we're actually going to use is the 20 feet, the half span or the run of the rafter. We need to find the height. How are we going to find the height? Well, the 8/12 is the slope. It's going to equal h/20. So we're going to do 8 times 20 divided by 12, which is going to give us 13.33. (13 feet and how many inches? 4 inches is the height. Now, the 13 point, we're going to write it in as 13.4, but we're going to keep that 13.33 handy because that's what we need to calculate with. Why do we need the 13.33? Because what we really want is the length of this out here. How do we find that length? Perfect. It's the square root of 20 squared plus 13.33 squared. Giving us 20.6559. So 20.656 feet. Oh, I did that wrong. Let me try that again. Yeah, that's not right. So 20 squared plus 13.3333 squared is 24.037. That sounds better. Now I'm going to keep that number as a decimal for now, but we're going to have to remember that we'll have to come back probably and change that to feet, inches, and sixteenths later. This here is 24.037. The next step, of course, is the longest jack rafter, which will also be how much? The same, 24.037. Now, what is step 3? The next longest jack. Yes, we're going to assume 2 feet on center unless we're told otherwise. Good question. Okay, very good. Yes, this is 20 here. This is going to be 18. So what we have is we have some triangles here. We have this one that is 20 feet by 24.037. This next one is going to be 18 by x, and x is what we're looking for. So we're going to have 20 goes to 18, as 24.037 goes to x, and then cross multiply and divide. So times 18 divided by 20, 21.633 feet. Now what?
Now do you want the jack rafter decrease?
Finally, we want the jack rafter decrease. You are correct, sir. So yeah, 24.037 minus 21.633 gives us 2.404. Now we got to convert that into feet, inches, and sixteenths. 2.404. Of course, I probably could have just left off the 2. So that's 2 feet. What do we do with the 0.404? Times 12 to make it inches. So we got 4.848. So that is 4 inches. We're going to subtract the 4. What are we going to do with the 0.848? Times 16 to make sixteenths. Very good. 13.5 or 14 sixteenths, which is 7/8 of an inch. So 2 feet, 4 7/8. What do you think? We haven't done that yet. That would be the last thing we could find here is the corner, the hip rafter. Well, we didn't find that yet. Hip corner. It's not even really step 5. We can do it actually pretty much anywhere from step 3 to 5. But the hip corner is just this hypotenuse on this triangle. So that's just the square root of the 24.037 squared plus 20 squared. $31.269. So, of course, that's 31 feet. We subtract the 31 times 12, 3 inches. Subtract the 3 times 16, 3.74 or 4/16 or 1/4 inch. So 31 feet, 3 1/4 inch. What do you think? Not so bad? What if we're talking about a valley instead of a hip? Well, once again, we are going to talk about a conventional valley where the slopes are the same on both sides. And we're going to start out with the simplest form of conventional valley, where not only are the slopes the same, but the spans are the same as well. So let's say this is 32 feet. This is 32 feet here as well. And let's say this is a 10-12 slope. So we need to find the length of the common rafter. It does not matter which side we are on because the slopes are the same, the spans are the same, the common rafter will be the same length here as it is over here. So step 1 is still the common rafter. What information is going to go in here? There we go. So we have 16 feet here. This is h. 10 over 12 equals h over 16, which is 13.33. So now, our common rafter length will be the square root of that 13.33 squared plus 16 squared. $20.827 feet. Which means this is 20.827 feet. How far is it from here to there? Well, half of this 32 or 16 feet. If the spacing's 2 foot on center, This jack then will be at how much? Let's say 14 feet. There we go. So that means we have 16 feet here with 20.827. Trying to find the length of this next jack. This is 14 and X. This is like step 3 we're on now. Well, I mean, this longest common rafter is the common rafter, so it's nothing really to do there. So you've got the 16 goes to 14. As 20.827 goes to X. So 14 times 20.827 divided by 16. 18.224. So then we shall subtract 20.827 minus 18.224, which will give us 2.603 feet. What are we going to do with that? We got the 2 feet. 0.603 will be times 12. You have 7.236, that's 7 inches. Subtract the 7 times 16, 3.7 or 4, which would be 1/4. 2 foot 7¼ inches is our difference between the jacks. Now we could find the valley corner rafter, which is this one right here. That's just going to be the 20.827 and the 16 squared. We won't bother calculating that out right now. I'm going to assume you guys can handle that on your own. Just the square root of the 20.827 squared plus 16 squared. So what are you thinking? You get her? Cool. Well then, we're going to look at a little bit less.
So you did that 20 squared, 16 squared.
Yeah.
You get
This here, that'd be for the valley corner here, this piece. Let's take a look at one more example. In this example, the two spans are not equal. But the slopes are still the same. What that means is, of course, that this peak doesn't tie into that peak. It hits partway up the roof. So we're going to go with the 612 slope. On this one, it does matter which common rafter we find. Because obviously the common rafter over here doesn't tie in real well. We want this common rafter over here. Now, to be honest, we could extend this up, and then we could just do our jacks there if we really wanted to. It's going to turn out to be the same. But let's do them over here where it makes a little more sense. So to find our common, we're going to be looking at that 18-foot span, 612 slope. What's our height going to be? This is 9. 612 slope will be 4.5, right? 612 slope, your height is half of your run. So you just do the 9 divided by 2. Do 6 over 12 equals h over 9. It's going to be 4.5. So then this length here is going to be the square root of 9 squared plus 4.5 squared. Equals 10.062 feet. Now what do we want to do with that?
that's the length of the longest one. So
The next longest one. Good. So we've got this triangle right here. This is 10.062. What's this here? What's this dimension? It's going to be half of the 18. That's going to be 9 feet. Since it's conventional, the setback here is going to be half of this span. This is what they call the main roof. And this is what they would call the L roof over here. This little part that sticks out the side. So then our second triangle, which I drew this little small here, it's going to look like this. Yes, it's always half. This is going to be 7 feet then for 2 foot on center. That'd be this piece right here to there. 2 feet less than the 9. So 9 goes to 7 is 10.062 goes to X. We cross multiply. 10.062 times 7 divided by 9. 7.826. So 10.062 minus 7.826 is 6322. 2.236. So that is 2 feet. Take the 0.236 times 12 is 2 minus 2 times 16. 13 sixteenths. There we go. I think with that, I am ready to turn you loose. You need to finish up what we did from last time if you didn't finish it. Then also on page 290 of the packet, sorry, not 290, page 289 of the packet.
We don't have to do a corner, please?
Yeah, you should. What we're going to do, page 289, there's only one problem, parts A, B, and C. For each of those, I want you to find, well, see, the corner on this doesn't go all the way up. That's why it's kind of tricky. But the corner would just be the length of the hypotenuse of this triangle here. We just use those two is all.
Do you want us to do that?
Yeah, we'll put that in. For each of those, I want you to find the jack rafter decrease. And the length of the valley corner.